Welcome to our discussion. Today we'll explore two fascinating research papers that use technology to shed light on the complexities of the transatlantic slave trade. The first paper details the creation of an augmented reality AR tour at the University of Pennsylvania, revealing the university's hidden history of complicity in slavery. The second paper uses mathematical modeling to map the uncertainties surrounding the origins of 19th century West African slaves. Let's start with the AR tour. What was the impetus for this project?
The University of Pennsylvania in 2006 and 2016 publicly denied any connection to slavery. However, research initiated in 2017 by undergraduate students under Professor Kathleen Brown uncovered significant evidence of the university's deep involvement, extending beyond simple slave ownership to encompass financial practices, medical education, and the enduring legacy of slavery on campus. This research formed the basis of the Penn Slavery Project, PSP.
So the AR tour isn't just about listing names of slave owners.
Exactly. The PSP aimed to redefine complicity beyond ownership, acknowledging the multifaceted ways in which the university benefited from and contributed to the institution of slavery. The AR app acts as a digital interruption, overlaying historical information onto the physical campus, challenging the university's previously presented narrative.
How does the AR technology work in practice? Can you give us a specific example?
The app features 6 immersive stops, each focusing on a specific location and aspect of Penn's history. For instance, at the Benjamin Franklin statue, the app overlays a historical portrait of Caesar, an enslaved individual, allowing users to hear his story through a reenactment. It's a powerful way to confront uncomfortable truths in a visceral and engaging manner.
That sounds incredibly impactful. What kind of community engagement was involved?
The project collaborated extensively with activists and the wider community, ensuring that the narratives were authentic and inclusive. This collaboration extended to the design and content of the AR exhibits, ensuring diverse voices were heard. The project also faced delays due to the COVID-19 pandemic, but it persevered, adapting to a virtual launch.
Let's shift gears to the second paper. This one uses a very different approach, mathematical modeling, to understand slave origins. What's the core challenge this paper addresses?
The challenge is the scarcity of reliable historical records detailing the origins of West African slaves. Oral histories and fragmented written accounts leave significant gaps in our understanding. The paper proposes a 2-part mathematical model to address this: a conflict intensity surface to estimate slave capture locations, and a Markov decision process to model slave transport to coastal areas.
A conflict intensity surface? How does that work?
The researchers used data on battles and destroyed towns within the Oyo Empire to create a continuous map of conflict intensity. This map isn't just about pinpointing battle locations. It estimates the broader regions where slave captures were most likely to occur, considering the movement of armies and the raiding of villages.
And the Markov decision process? That sounds quite technical.
It's a mathematical model that simulates the movement of slaves through the existing trade network. It considers factors like distances between cities and the intensity of conflicts along the routes, predicting the most likely paths slaves would take to reach coastal ports.
So you're essentially creating a probabilistic model of slave journeys.
Precisely. By combining the conflict intensity map and the Markov decision process, the model generates a conditional probability map. This map shows the likelihood of a slave originating from a specific region, given their known port of departure.
This sounds like a powerful tool for genealogical research.
Absolutely. It allows researchers to trace potential origins of enslaved individuals, even in the absence of direct historical records. The model also considers the impact of conflicts on slave routes, offering a more nuanced understanding of the dynamics of the internal slave trade.
What data did the researchers use to build and validate their model?
The model uses geopolitical data sets describing trade routes and conflicts during the Oyo Empire's collapse, roughly 1816, 1836. This includes data on conflict locations and intensities, city locations and existence periods, and estimates of slave departures from various ports. The model's accuracy is validated by comparing its predictions to available ship logs and, more recently, to emerging linguistic data from transliterated slave names.
How does the linguistic data help validate the model?
Transcribing and translating the names of enslaved individuals from ship manifests provides valuable information about their likely ethnic and linguistic origins. By comparing the model's predicted origins with these linguistic data, researchers can assess the model's accuracy and refine its parameters.
What are some of the limitations of this model and what future work is planned?
The model relies on existing historical data, which is inherently incomplete. Future work will focus on incorporating additional data sources, such as genetic information and more comprehensive linguistic data, to improve the model's accuracy and expand its scope. The model could also be adapted to study other forced migrations, such as those experienced by indigenous populations in the Americas or during the Holocaust.
The authors also created an interactive web application to make their research accessible to a wider audience. What are the key features of this application?
The web application allows users to interactively explore the model's results. Users can select a year and port of departure, and the application generates a probability map showing the most likely regions of origin for slaves departing from that port during that year. The app also displays the conflict data, conflict intensity maps, trade networks, and state borders, providing a rich visual context for understanding the model's findings.
What are the broader implications of these two projects?
Both projects highlight the power of technology in uncovering and interpreting historical narratives, particularly those involving marginalized communities. The AR tour provides a powerful and engaging way to confront uncomfortable truths about the past, while the mathematical model offers a novel approach to addressing the challenges of incomplete historical data. Both projects underscore the importance of collaborative research and community engagement in historical scholarship.
The AR project seems to focus on a specific institution's complicity, while the mathematical model takes a broader regional approach. How do these different scales of analysis complement each other?
They offer complementary perspectives on the same overarching issue. The AR tour provides a micro-level analysis, focusing on a specific institution's role in slavery. The mathematical model provides a macro-level analysis, examining the broader regional dynamics of the slave trade. Together, they offer a more complete picture of the complex historical forces at play.
The AR project faced challenges due to the pandemic. What lessons can be learned from this experience regarding the implementation of similar projects?
The pandemic highlighted the importance of flexibility and adaptability in digital humanities projects. The PSP's successful transition to a virtual launch demonstrates the potential of online platforms for disseminating historical research and engaging with wider audiences. Future projects should incorporate contingency plans for unforeseen circumstances, such as pandemics or technological disruptions.
The mathematical model relies on several assumptions and parameter choices. How robust are the results to these choices?
The model's robustness is an ongoing area of research. The researchers have explored the sensitivity of the results to different parameter choices, such as the bandwidth in the kernel density estimation and the cost of movement through conflict regions. Future work will focus on further evaluating the model's sensitivity and exploring alternative modeling approaches. The availability of additional data, such as genetic information and more complete linguistic data, will also help to refine the model and assess its robustness.
Both papers emphasize the importance of community engagement. How can this be best achieved in future projects of this nature?
Meaningful community engagement requires a collaborative and participatory approach. Researchers should actively involve community members in all stages of the project, from the initial research design to the dissemination of findings. This includes ensuring that the narratives are authentic and representative of the experiences of marginalized communities. Open communication and transparency are also crucial for building trust and fostering collaboration.
The mathematical model could be applied to other historical contexts. What are some of the most promising areas for future application?
The methodology could be adapted to study other forced migrations, such as the displacement of indigenous populations in the Americas or the transatlantic movement of indentured servants. The model's ability to map uncertainty in the presence of incomplete data makes it a valuable tool for exploring a wide range of historical questions. The key is to adapt the model to the specific characteristics of each historical context, carefully considering the available data and the relevant factors influencing migration patterns. The development of similar interactive web applications could also greatly enhance the accessibility and impact of this type of research.
Thank you for this insightful discussion. The work presented in these papers offers valuable contributions to our understanding of the transatlantic slave trade and the power of technology in historical